Bismillahirrahmanirrahim. Assalamu alaikum. I am Aziza Munir and we will be discussing normal distribution in today's session. We have already discussed discrete distribution in detail in previous lectures, in which we have analyzed that how a random variable need to do with the probability, and when this random variable through estimation is determined by probability, describes which type of results, right? So we have gone through in detail with the uniform discrete distribution, with the binomial distribution, and the mean and variances of the binomial distribution. So in an extension to the binomial distribution, we will be talking about normal distribution today. So the binomial distribution incorporates two variables usually, or it's a kind of scenario in which the mean and variances of a binomial distribution describes a situation in probability estimates when more than one variable is in consideration. So when we are talking about a continuous distribution, we will apply, we need to know the results which we have taken from the binomial distribution and see that whether this discrete distribution affects the normal distribution or the continuous distribution or not. So there must be any two types of distribution which might be in understanding. One is which determines the discrete results, and the other which determines the continuous results. Or there are two types of data sets. One is the discrete and the other one is continuous. So in measuring the responses and measuring the two data sets, we need to apply two different techniques. One is the binomial one and the other one is the normal one. So normal distribution is usually or is undoubtedly by all means applied when you are running a continuous distribution. Then in today's lecture we will be checking that what is the check for normality is, and how we can create an approximation of normal towards the binomial distribution, as well as the application of normal distribution with the help of examples. So let's start with the continuous distribution from the discrete analysis. For a discrete distribution, for example, in binomial distribution, if n is equals to 5 and the probability which is determined by p is equals to 0.4, definitely it states that q is equals to 1 minus p, which is 0.6. So we have already taken this in consideration, that q is equals to 1 minus p, where p is equals to 0.4, then q is equals to 0.6, which is 1 minus p. So we are given with n is equals to 5. So we are provided with 5 observations in which frequencies are presented in 0.0776, 0.2592, 0.34, etc. And with the help of these frequencies, we can apply a discrete tabulation. We can apply a discrete chart over it. Now, if you just analyze कि हम किस तरह से normal case की plotting करते हैं, वो derive होती है discrete के case. As I've just said कि in order to apply continuous distribution, you should have a knowledge of the discrete probabilities or the discrete applications. तो यहाँ पर हमने जो example discuss की है, वो basically discrete की discuss की है. Here, if we are having a discrete plot, तो इन सारे histograms का अगर हम top height मालूम कर लें और उसको हम ये जिस तरह मैं आपको शो कर रही हूँ red dots, अगर हम उससे इसको measure कर लें कि what is the height of each histogram which is mentioned in a discrete distribution, and combine these dots together. If we combine these dots together, we come up with a kind of distribution which is normal in range. So this shows that there is a sequence of observations appearing under this normal distribution, under this normal curve, which are extensively lying in the distribution. When we are talking about a histogram, we are of the opinion that 5 observations have been considered, in which the relative frequencies are given, and with each relative frequencies we can come up with 1 point. If the relative frequencies are not that sharply given, then we can come up with the presence of each frequency under the normal distribution curve if we know the exact height. So if we're just known with the mean and variance or mean and standard deviation of the curve, we can easily plot that what is the height and what should be the right width of the curve, which can compensate the maximum values. So the major difference between discrete and the continuous probability distribution is that the discrete one is incorporating multiple given frequencies on discrete level, whereas the continuous frequencies, if are mentioned, then we'll be using the normal distribution curve. So for a continuous random variable, we also represent probability by areas, not by areas of rectangles, but by areas under continuous curves. So that is something which distinguishes the discrete as well as the continuous random variable, that in a continuous case we are already provided with the rectangles, we are already provided with frequencies, but these are not represented by rectangles but through a continuous curve. For a continuous random variable, the place of histograms will be taken by continuous curves. So therefore it has been the histograms are actually being removed with the normal curve. So imagine a histogram with narrower and narrower classes, then we can get a curve by joining the top of rectangles as we have just done. This continuous curve is called a probability density or probability distribution. So a continuous distribution for any x holding probability of x is equals to x, which is 0, for a continuous distribution the area under a point is 0. Can't use probability x is equals to x to describe the probability distribution of x. जब हम कहते हैं कि जी एक पॉइंट के अंदर इतनी वैल्यूज एग्जिस्ट करती हैं तो उसकी इतनी फ्रीक्वेंसी हुई, अगर हम कहते हैं कि एक पॉइंट पे इतनी फ्रीक्वेंसीज को ऑकर करने की प्रोबेबिलिटी 0 है, तो इसका मतलब यह है कि उस पॉइंट के अंदर जो एरिया है वो 0 होगा. इसलिए जो कोई एक स्पेसिफिक पॉइंट ऐसा नहीं है जिसकी बेसिस के ऊपर हम एक हिस्टोग्राम क्रिएट कर लें. हमने उसकी डिग्री ऑफ वेरिएशन को बहुत माइन्यूट कंसिडर कर लिया है, इतना माइन्यूट कंसिडर किया है कि वी आर जस्ट फॉलोइंग इट अंडर द एरिया of the continuous distribution. We are not identifying any histogram, because if the density of the histogram is being removed, if the density is being so stricken, if the density is being so tightened that we cannot identify it with a specific area under the histogram, but we just identify a line. So if we are just identifying a line, we are saying that we are coming up with a point on a normal distribution curve, or we are coming up with a point on the normal curve. So this point is holding 0 area under it, because if you're talking about a histogram, we are definitely talking about a specific structure or a rectangle which is holding certain values, which is holding certain data in it. But if we're talking about a point, or if we're talking about a line on a normal curve, it won't be holding certain area under it. So therefore the area under the point is equivalent to 0. Instead of taking one variable in consideration, one value in consideration and identifying its frequency, we talk about a range between two variables, or range between 2 points. These 2 points will be either A or B, or we are taking the probability of it. So that is something which is determined by probability of x, so that x lies between A and B, where A is the minimum factor and B is the maximum factor. So a curve of x shows that frequency of x is greater than 0 in the given case. यहाँ पर जो density function है वो show कर रहा है कि जो 0 की frequency है, it is greater than the frequency of x is greater than and equivalent to 0. तो below 0 जितने भी points हमारे पास exist करते हैं in the given set of values, जहाँ पर जो x axis हमें mention कर रहा है, in the given set of values, whatever is the given frequency, it is lying between, it is maximized till 0. If it is maximized till 0, meaning that all the values which are appearing in these x-axis values will be fallen between 0.00 to 0.01. So यहाँ पर जो area under the curve है, that will be determined by 1, and we are interested in knowing the distance between 2 points which are A and B, which are determined by the x, and the area of A and B would be measured with the reference of greater than and less than notions. So here we can say that the probability, if you're interested in knowing the probability of x when x lies between 2 and 4, तो यहाँ पर हमारे पास दो set of values given है कि हम मालूम करना चाह रहे हैं कि x जो है वो lie करता है 2 और 4 के दरमियान में, when 2 and 4 are inclusive. This line shows that if we are saying that probability of x where x is greater than or equals to 2, then there might be a case that x is equivalent to 2. Or if we are saying that x is less than or equivalent to 4, meaning x cannot be greater than 4 but can be equivalent to 4. So if we just split this relationship, we can come up with this relation at first, that x is greater than or equivalent to 2 and less than 4, plus probability of x is greater than 2 but is less than and equivalent to 4. You must hold a sign equivalent to here as well. That probability of x is greater than 2 and it is holding that x is greater than is less than and equivalent to 4. In the graphical representation we can show that the similar line जो हमने भी बात की कि हम यहाँ पर कोई histogram नहीं बना सकते कि कितनी frequencies appear हो रही हैं एक particular point के ऊपर. So we are just identifying a point on normal curve which is identifying that 2 lies on the point on the curve. And as x is equivalent to 2, that is why we have included x in the given area. Similarly, we have identified that x cannot be greater than 4, but it has to include every single value which is less than 4. So with this point on the normal distribution curve, we have identified that 4 is the point which lies on the curve and which shows that x might be equivalent to 4. So we are interested in knowing that what is the probability or we want to know the area which describes that x lies between 2 and 4, where 2 and 4 are inclusive in it. So in that case, the normal distribution is holding multiple properties. One very important issue is that the normal curve is a bell-shaped curve and its density is presented by 1 over sigma under root 2 pi, and in its exponent it exists minus x minus mu over 2 sigma square whole square. So that is something which is which shows the normal distribution measurement. यहाँ पर जो exponent में हमें जो ratio नज़र आ रही है, which is x minus mu over 2 sigma square, this is actually the standard ratio. इसको हम standard ratio भी consider करते हैं. और जब भी हम normal distribution को measure करते हैं through z, तो वहाँ पर हम standard ratio को use करते हैं. Our standard ratio is equivalent to x minus mu over 2 sigma square. So in that case, we talk about that this function, if this function remains constant, then the entire value of z is determined by this standard ratio, where mu and sigma square are two parameters of determining the curve, which are the mean and variances respectively of normal population, where sigma stands for the standard deviation and sigma square is equals to the variance. Now the curve is in front of you, which describes that how this curve changes its shape. Now we will discuss it, that it's a normal bell-shaped curve where mu is equals to 100 and variance is equals to 10. So in that case, अगर हमारे पास जो mean है वो 100 हो, तो this line actually shows that mu is equals to 100. If it lies in the center, this shows the mean. तो यहाँ पर हमें पता लग रहा है कि mean हमारे पास mu है, which is equivalent to 100. So this line is actually showing that mu is equals to 100. Now how we can analyze that sigma square is equals to 100 is bearing any change on this curve? This can be monitored, this can be seen that sigma square is basically the variation. Sigma square usually describes or actually describes the variation, where we talk about sigma is equals to standard variation or standard deviation. यहाँ पर जो इस कर्व की डेंसिटी है या इसकी जो इरेक्शन है, हम स्टैटिस्टिकल टर्म में इसकी स्क्यूनेस कहते हैं कि कितनी हाइट तक पहुंचना चाहिए ये कर्व, ये डिटरमिन करता है हमारा स्टैंडर्ड डेविएशन। तो इफ वी नो दैट मीन रिमेन्स द सेम, लेकिन हमारी जो स्टैंडर्ड डेविएशन है वो चेंज होती जाए, तो इसकी जो पीक है या इसकी जो हाइट है इस कर्व की, वो कभी ज़्यादा हो जाएगी, कभी कम हो जाएगी। तो इसका मतलब ये है कि ये कर्व की जो फ्लैटनेस या इसकी इरेक्शन जो है या इसकी हाइट जो है, ये डिटरमिन करती है सिग्मा स्क्वायर के ऊपर या फिर स्टैंडर्ड डेविएशन के ऊपर। इस केस में एक नॉर्मल डिस्ट्रीब्यूशन का कर्व है जिसमें म्यू 100 शो हो रहा है और स्टैंडर्ड डेविएशन 10 के वेरिएशन 10 के इक्विवेलेंट है, और यहाँ पर आपको एक कर्व की शेप नजर आ रही है विच इज नॉर्मली डिस्ट्रीब्यूटेड। इस केस में अगर आप देखें तो यहाँ पर हमारे पास मीन चेंज हो गया है। फर्स्ट कर्व अगर हम मेंशन कर्व में गिवन डायग्राम के अंदर इस कर्व को कर्व 1 कंसिडर करें, तो यहाँ पर हमारे पास मीन जो है वो 0 शो हो रहा है एज इट इज मेंशन्ड हियर। सो इफ मीन इज 0, दिस कर्व इज शोन, मीनिंग one curve is presenting a situation where mean is 0. If the mean of any observation changes, meaning we come up with any additional observations in the given set of observations through which our mean changes from 0 to 5. If our mean changes from 0 to 5, in that case the entire curve will shift from 0 to 5. So therefore we have come up with another curve from which we are having mean which is shown as 5. So the curve 2 shows that mean is equals to 5 and curve 1 shows that mean is equivalent to 0. Now the point which is notable here is that in both the curves variation or variance is similar, which is equivalent to 1. So if it is equivalent to 1, the height of two curves and the shape of two curves is the similar. If the height and shape of two curves is similar but their position is changed, this position is changed on the basis of mean, change in mean. But if we are interested in knowing that mean of the given observation remains the same, but due to any change in the number of in the degree of observations or in the density of observations, we have seen that the variance or the standard deviation is changing. In that case, if we have known that mean is equivalent to 0 and this curve, this is curve 1, in which mean is equals to 0 and standard deviation is equals to 1, variance is equals to 1. If variance is increased by 1 to 2, meaning इसकी जो density है वो altogether change हो जाएगी. If this is curve 2, तो in this case as well हमारे पास जो mean है वो अभी भी 0 के ही equivalent है, लेकिन जो curve 2 हमें जो position show कर रहा है वो एक डिफरेंट डेंसिटी शो कर रहा है, वो एक डिफरेंट पिकेडनेस शो कर रहा है कि कितनी पीक के ऊपर जाकर कर्व अपनी मैक्सिमम हाइट टच करेगा, वो डिटरमिन करता है हमारा वेरिएंस। अगर वो हाइट ज़्यादा होगी तो उसका मतलब ये है कि वेरिएंस ज़्यादा है, अगर वो हाइट कम होगी तो उसका मतलब है कि वेरिएंस कम है। सो देयर वन वेरी इंपॉर्टेंट थिंग which need to be remembered here is that whenever there is change in mean, the entire curve will change its position. But when there is any change in the variance, then the pickedness or the height of the curve will be affected. Now in that case, when height and position of the curve are both changed, this shows that mean and variance of the two curves both are changed. Now in the first curve, when mean is equals to 0, and variance is equivalent to 1, in that case we are having this curve, meaning here we are measuring this as curve 1, जहाँ पर हमारे पास mean 0 है। जब mean हमारे पास 2 हो गया, in that case the entire curve has been shifted, but variance is reduced from 1 to 0.25. तो in that case जो उसकी height है mean की curve की वो skew हो गई, वो बहुत ज़्यादा dense बहुत ज़्यादा shrink हो गई है। in that case जो pickedness है वो increase हो गई है। so curve 2 के केस में जो हमारा curve है वो ज़्यादा height show कर रहा है। which is showing comparatively low variation. So that is something which is determined when mean and variance both are changed in any form of distribution. जो स्टैंडर्ड नॉर्मल कर्व है उसके अंदर हमारे पास मीन 0 होता है और वेरिएंस को हम अज्यूम करते हैं कि दिस इज इक्विवेलेंट टू 1. Now how to calculate the probability of a normal random variable? Now each normal random variable x has a density function, say f of x is a normal curve. So अब हमने अभी तक तो हमने आइडेंटिफाई कर लिया कि किस तरह से हम मीन को कैलकुलेट करते हैं, किस तरह से हम नॉर्मल डिस्ट्रीब्यूशन को एनालाइज करते हैं विद रिस्पेक्ट टू चेंज मीन एंड वेरिएंस. नाउ वी विल आइडेंटिफाई दैट हाउ टू कैलकुलेट प्रोबेबिलिटी ऑफ अ नॉर्मल रैंडम वेरिएबल. Now for that we need to keep in mind few points. At first, that each normal random variable x has a density function, say f of x is a normal curve. हर जो वेरिएबल है रैंडम वेरिएबल x उसका एक डेंसिटी फंक्शन होगा जो कि रिप्रेजेंट होगा f of x से, which is usually described by the frequency that the frequency of x which is appearing in the given set of observations. Then the probability of x lies between 2 points of a and b, where a is the smaller point, or a is the minimum point and b is the maximum point, and we are interested in knowing the difference between 2 points, that is the area between 2 points, which is the area under the normal curve of f of x. The table 1 which we are about to see gives a standard normal curve with mu is equals to 0 and sigma is equals to 1. जो हमारे पास टेबल अभी हम जिसको लोकेट करते हैं और आइडेंटिफाई करते हैं और उसको हम रीड करने का तरीका भी देखते हैं, वो टेबल बेसिकली एक स्टैंडर्ड नॉर्मल कर्व के ऊपर बना हुआ होता है which assumes that mu is equals to 0 and standard deviation is equals to 1. Probabilities for any normal curve that is mu and sigma can be rewritten in terms of standard normal curve. जो probabilities है normal curve की वो mu और sigma दोनों की फॉर्म में rewrite हो सकती हैं in terms of the normal curve. Now z denotes the standard normal random variable, and standard normal curve is symmetrical about the origin which is 0. So जो हमारा curve है वो usually determine करता है z से, determine होता है z से, and this is known as the standard normal random variable, which shows that it is symmetrical and it is symmetrical about from the origin that is 0. ये वो टेबल है जिसके ऊपर अब हम बात कर रहे थे कि this determines the distance between two variables under the curve, and this is identified through these values of z. So in that case, if we are having a value of for example 0.13, 0.13, if we are interested in knowing that what is the area lying in the z distribution of 0.13, so we can read this as 0.1 under 0.03 column, so this will be 0.0517. So that is how we actually read this table कि अगर हमने एक वैल्यू आइडेंटिफाई करनी हो, अगर हमें पता हो कि हमारे पास नॉर्मल डिस्ट्रीब्यूशन का ये कर्व है और हमने दो वैल्यूज़ के दरमियान में, फॉर एग्जाम्पल दिस इज 2 and 4, हमें दो वैल्यूज़ के दरमियान में रिलेशनशिप मालूम करनी है जहाँ पर हमारे पास म्यू और स्टैंडर्ड डेविएशन गिवन है, तो वहाँ पर हम स्टैंडर्ड नॉर्मल फंक्शन अप्लाई करेंगे विच इज़ डिटरमिन्ड बाय z, विच इज़ x माइनस x बार ओवर सिग्मा ओवर अंडर रूट n. तो यहाँ पर इस स्टैंडर्ड नॉर्मल फंक्शन की बेसिस के ऊपर हम कैलकुलेट करेंगे अपनी वैल्यू और उस वैल्यू को डिटरमिन करेंगे नॉर्मल डिस्ट्रीब्यूशन के कर्व के अंदर. फॉर एग्जांपल हमने डिटरमिन करनी है इसकी वैल्यू, फॉर एग्जांपल 0.13 आती है, तो हम ये देखना चाह रहे हैं कि कितना परसेंट एरिया बिटवीन दीज वैल्यूज एग्जिस्ट करता है. सो दिस विल बी 0.13 एज इट इज शोन फ्रॉम द रिलेशनशिप ऑफ रोज एंड कॉलम्स. सो यहाँ से जो हमारे पास वैल्यू आई है 0.0517, it shows that 5% of the curve of the area between these values is lying under the curve. Now we can see it with multiple examples that if we are interested in knowing the area between 0 and 1 in the curve, we can see that it is 0.3413. If we refer towards the curve towards the table again, we can see that between 0 and 1 how much area is lying. So we are interested in knowing this position, So this determines through 0.3413, which is the given point under the curve. So from non-standard normal to standard normal curve, you need to know that x is a normal random variable with mean mu and standard deviation sigma. We set as z, which is equivalent to x minus mu over sigma, or z is equals to standard unit or z score of x. Then z has a standard normal distribution and x is a normal, we can see it through an example that if x is a normal random variable with mu is equals to 120 and sigma is equals to 15, और इस केस में अगर हमने probability find out करनी है कि x is less than and equivalent to 135, तो 135 एक ऐसा point है जो कि normal curve के ऊपर कहीं पे exist करता होगा, लेकिन हमें उसकी एग्जैक्ट लोकेशन नहीं पता. हमें बस ये पता है कि मीन जो है वो 120 है और उसकी जो स्टैंडर्ड डेविएशन है वो 15 है. लेकिन दो तीन चीज़ें हमें यहाँ से क्लियर हो रही हैं, और वो ये कि अगर हमारे पास ये नॉर्मल डिस्ट्रीब्यूशन का कर्व है तो उसका मीन विल डेफिनेटली अ सेंट्रल वैल्यू दैट विल बी 120. एंड इफ यू वांट टू नो अ पॉइंट which shows that x is less than or equivalent to 135, तो 135 डेफिनेटली एक ऐसा पॉइंट होगा जो कि मीन से बड़ा है. तो हम एनालाइज करना चाह रहे हैं x को एक ऐसा point which is through which we can analyze a data between mean and the given point. So in that case, x which is provided to us in the form of mean is known as 120, and the point from which we want to analyze the data is 135. So in that case, we will be determining the value with the help of x minus mu over sigma, where mu is equivalent to the mean. So x minus 120 over 15, as 15 is the standard deviation. So according to the normal distribution, we can have mu of z is equals to 120 minus 120 over 15 is equivalent to 0. Or we can say that 15 over 15 is equivalent to 1, which shows that standard deviation. यहाँ ये उस वक्त नॉर्मल होगा जब हमारे पास मीन 0 होता है और स्टैंडर्ड डेविएशन 1 होता है. सो ये एक स्टैंडर्ड नॉर्मल सिचुएशन है जिसमें मीन इज इक्वलेंट टू 0 और स्टैंडर्ड डेविएशन इज इक्वलेंट टू 1. जब हमारे पास गिवन सिचुएशन के ऊपर इसे हम अप्लाई करते हैं जहाँ पर हमें मेंशन है कि x इज लेस देन एंड इक्वलेंट टू 135, तो यहाँ पर हमारे पास स्टैंडर्ड नॉर्मल फंक्शन इज लाइंग लेस देन एंड इक्वलेंट टू 135 minus 120 over 15, where this function x minus mu over sigma is already equivalent to z. तो यहाँ पर हम mention कर देंगे z, which is less than or equivalent to 1, which shows 0.5 plus 0.3413. तो ये 0.3413 हमारे पास कहाँ से आया है? 135 को जब हम 120 में से माइनस करेंगे तो we will be obtaining a value of 15. तो 15 over 15 is equivalent to 1. 1 को अगर हम आइडेंटिफाई करें कि 1.0 की वैल्यू अगर हम इस कर्व में देखेंगे कि वो कहाँ है, तो 1.0 exists here with the 3413. That is the point जहाँ पर 1.0 के अगेंस्ट वैल्यू एग्जिस्ट कर रही है. तो 3413 is the point जिसको हमने 0.5 के अंदर ऐड किया है, तो हमारे पास 0.8413 का नंबर आया. Another interesting point to note here is that why we have added this. Why not minus sign? Because 135 is greater than 120 and we want to know the area which is lying under this curve, between this curve. If we want to know a point on the other side of the curve, 135 is greater than 120. 120 is the mean, and that is why we have placed it on the right side of the curve, which shows positive values. If we know that 120 is the mean, and if we want to know that what is the area might be lying and if it is 60, तो इस केस में यहाँ पर हम जो प्लेसमेंट करेंगे इस पॉइंट की वो करेंगे हम लेफ्ट साइड के ऊपर, which is the negative portion of the curve. So in that case हमारा ये वाला जो प्लस का साइन है वो माइनस के साइन में चेंज हो जाएगा. तो इम्पॉर्टेंट चीज़ यहाँ पर नोट करने वाली ये है कि if our given point of probability estimates is greater than mean, then we will be calculating it with 0.5 plus the given value from the normal distribution table. And if we want to know any value which is the probability of any value which is less than mean, then we will be interested in negative sign, or we will be deducting that point from the normal point curve and analyzing the results. So here too, if we continue the given example, and instead of 135 we come up with another point which is greater than mean, which is 150. So in what will be that scenario? In that case we will be talking about instead of writing 135, we will be mentioning 150 minus 120 over 15, which shows 30 divided by 15, which is equivalent to 2. In that case probability of x is less than or equals to 150 is equivalent to probability of z, which is less than or equivalent to 2. तो यहाँ पर less than or equivalent to 2 के केस में हम अपने टेबल के अंदर से ही 2.0 के अगेंस्ट वैल्यू नोट डाउन करेंगे. हमारे पास गिवन टेबल के अंदर 2.0 तक का टेबल एक्सटेंडेड फॉर्म में मेंशन नहीं है, लेकिन जब आप अपनी बुक्स के अंदर नॉर्मल डिस्ट्रीब्यूशन का टेबल देखें तो वो 5 तक मेंशन होता है. वहाँ पर अगर आप 2.0 के अगेंस्ट वैल्यू नोट डाउन करें तो दिस इज कमिंग एज 0.4772. तो 0.4772 को अगर हम 0.5 के अंदर ऐड करें, ऐड हमने इसीलिए किया है क्योंकि जो वैल्यू है 150 वो मीन से बड़ी है. इट इज लाइंग ऑन द राइट साइड ऑफ द कर्व that shows a positive values, so that is 0.9772, meaning that if you are interested in knowing that what is the probability of z is less than or equivalent to 150, so 97% of the area will be covered under that curve. Now how to check normality? Most of the statistical tools used to assume normal distributions. In order to know if these are the right tools for a particular job, we need to be able to assess if the data appear to have come from a normal population or not. So a normal plot gives a good visual check for normality. जितना ज़्यादा normal curve के ऊपर जितना ज़्यादा अच्छा normal हमें data मिलेगा population से, उतना ही बेहतर plotting होगी हमारी normal curve के ऊपर. ये हमने सिमुलेशन एक कंसिडर की है 100 ऑब्जर्वेशंस की, वेयर मीन इज स्टैंडिंग 5 एंड स्टैंडर्ड डेविएशन इज पुटिंग अ वैल्यू ऑफ 1. इन दैट केस वी आर कमिंग अप विद द जनरलाइजेशन ऑफ सिमुलेशन विद नॉर्मल डिस्ट्रीब्यूशन, दैट हाउ वी कैन एनालाइज थ्रू क्वांटाइल पोजीशंस दैट व्हाट विल बी द पोजीशन ऑफ द कर्व. तो यहाँ पर हमने इन डेंसिटी मल्टीपल पॉइंट्स को 100 पॉइंट्स को 100 ऑब्जर्वेशंस को प्लेस किया है, जो कि हमें इन कंटिन्यूटी की फॉर्म में प्रोवाइड कर रही हैं डेटा. इसी कर्व को अगर हम एक्सटेंड करते जाएंगे तो हमारे पास एक पॉइंट ऐसा आएगा जहां पर मीन 5 के फॉर्म में एग्जिस्ट कर रहा होगा. इट विल बी एनी पॉइंट विच इज हायर देन द गिवन वन एंड इन विच द स्टैंडर्ड डेविएशन इज शोइंग एज वन नंबर. So this particular plot is the result of alpha fetoprotein level, that is AFP level in maternal breast for normal or Down syndrome fetus. तो यहाँ पर हमारे पास एक एस्टिमेट हमने किया है एक वुमेन रिस्क एंटिसिपेट किया है ऑफ हैविंग pregnancy of associated with Down syndrome using her age and सीरम अल्फा फीटोप्रोटीन लेवल. ये एक मेडिकल रेफरेंस के अंदर हमने एक एग्जांपल कंसिडर की है कि अगर हमारे पास एक नॉर्मल पॉपुलेशन एग्जिस्ट करती है ऑफ वुमेन की और उसमें हमने एनालाइज करना है एवरेज अल्फा फीटोप्रोटीन लेवल मैटरनल ब्रेस्ट के अंदर, तो यहाँ पर नंबर ऑफ ऑब्जर्वेशंस के अगेंस्ट हम मेजर करेंगे नॉर्मल प्लॉटिंग को. ये जो कर्व आपको हायर फॉर्म में नजर आ रहा है ये एक नॉर्मल सिंड्रोम शो कर रहा है. दिस इज अ नॉर्मल सिंड्रोम. और ये हमारे पास प्लॉटेड सिंड्रोम है, जो हमारे पास मल्टीपल वैल्यूज को हमने 100 वुमेन के टेस्ट को एनालाइज किया और यहाँ से उनकी फीटो प्रोटीन लेवल को अल्फा फीटो प्रोटीन लेवल को चेक करके मल्टीपल वैल्यूज प्लॉट की हैं और वहाँ से एक कर्व इरेक्ट किया है. इस प्लॉटिंग में और जो गिवन प्लॉटिंग है उसके अंदर जो डेविएशंस हमारे पास आएंगे वो हमारे पास एक चेक फॉर नॉर्मेलिटी शो करेगा. Further details are mentioned on the slide and you might read them for your further information. The normal plot is the way these normal plots work. That straight means that the data appear normal and parallel means that the group have similar variances. ये जो previous हमने example show की है इसके अंदर we have analyzed very clearly कि जो data appear हो रहा है वो straight line की form में show हो रहा है, जिसका मतलब ये है कि इनके means जो है वो similar है. और पैरेलल ये इसलिए आ रहे हैं इसलिए क्योंकि इनके जो वेरिएंसेस हैं उनके अंदर कोई चेंजेस नहीं है. तो जो स्टैंडर्ड नॉर्मल कर्व है, जो स्टैंडर्ड नॉर्मल प्लॉट है और जो गिवन वैल्यूज प्लॉट है, दिस इज ऑलमोस्ट डिटरमिनिंग द इक्विवेलेंट वैल्यूज व्हिच शो स्ट्रेट मीन्स एंड पैरेलल डेटा सेट्स विद सिमिलर वेरिएंसेस. इन नॉर्मल प्लॉट in order to plot the data and check for normality, we compare two areas. One is our observed data with the what we expect from the sample of the normal data. तो जब भी हमने नॉर्मेलिटी चेक करनी होती है तो उस केस में हमारे पास एक स्टैंडर्ड फॉर्मेशन होनी चाहिए, और वो स्टैंडर्ड फॉर्मेशन हमारे पास उस वक्त आएगी जब हमारी पॉपुलेशन हमें एक नॉर्मल सेट ऑफ डेटा प्रोवाइड कर रही है। उस केस में जो नॉर्मल कर्व हमारे पास ऑलरेडी गिवन है उसको हम प्लॉटेड कर्व के साथ मैच करेंगे। उस कर्व का अगर मीन और वेरिएंस सिमिलर है तो उस केस में दोनों कर्व्स की जो डायरेक्शन है वो पैरेलल एग्जिस्ट करेगी। अगर वो पैरेलल है तो इसका मतलब ये है कि जो डेरिवेशन है हमारी, जो चेक ऑफ फॉर नॉर्मेलिटी है, दिस इज एक्यूरेट बिकॉज द मीन कंसिडरेशन इन टू प्लॉट्स इज सिमिलर as well as their variances are also similar. That is why the curves are giving the parallel results. So इस तरह से हमारे पास नॉर्मेलिटी चेक की जा सकती है कि जब हमारे पास एक स्टैंडर्ड नॉर्मल फंक्शन गिवन हो और हम स्टैंडर्ड नॉर्मल फंक्शन को कर्व के ऊपर प्लॉट करके अपनी गिवन प्लॉटिंग को, अपनी जिन ऑब्जर्वेशंस को हम आइडेंटिफाई करना चाह रहे हैं उनकी पोजीशन को, उसको हम उसके अगेंस्ट प्लेस करते हैं और वहां से आइडेंटिफाई करते हैं मीन और वेरिएंस के रेफरेंस में कि क्या हमारी प्लॉटिंग ठीक है या नहीं। अगर तो हमारी लाइंस जो है, अगर हमारा कर्व जो है वो स्ट्रेट इरेक्ट होता है तो इसका मतलब ये है कि इनके मीन्स जो है वो सिमिलर है, मीन्स इनके स्ट्रेट हैं। और अगर उनके अंदर अगर वो दोनों कर्व्स पैरेलल एग्जिस्ट करते हैं एक दूसरे के, तो उसका मतलब ये है कि इनके वेरिएंसेस सिमिलर हैं। नाउ इन द गिवन सिनेरियो, अगर जो आपको एग्जांपल पीछे नजर आ रही है स्लाइड्स में, इसमें मल्टीपल डेटा सेट्स की मल्टीपल ऑर्डर्ड वैल्यूज की बात हुई हुई है, जिसके अंदर हमने वैल्यूज की पोजीशन चेंज करके उनके डिफरेंट मीन्स को एनालाइज किया है, जो एक प्रैक्टिकल सिचुएशन शो कर रहे हैं कि यूजुअली जब हम प्रैक्टिकल ग्राउंड्स के ऊपर बात करते हैं तो हमारे पास मल्टीपल ऑब्जर्वेशंस एग्जिस्ट करती हैं जिनके अंदर स्लाइट वेरिएशन होता है। तो if we repeat the similar act of changing the presentation of values in the given graphical interpretation, तो in the given graphical presentation वहाँ पर अब उनकी values को सिर्फ हम आगे पीछे change करते हैं और multiple ordered values acquire करते हैं and we repeat this experiment again and again, तो हमारे पास यहाँ पर Z1, Z2, Z3 so on up till Z5 results मिलते हैं। To begin with, we imagine taking n phi is equals to 5 random values from a standard normal population where mu is equals to 0 and sigma is equivalent to 1. Let Z1, Z2 and Z3 up till Z5 be the ordered values. Suppose we do this over and over, in which multiple samples are presented to us, where mean is equivalent to minus 1.163 for first observation, minus 0.495 to second observation, and so on 1.63 to the fifth observation. On average, the smallest of n is equals to 5 standard normal value is 1.163 standard deviation below average. The second smallest of n is equals to 5 standard normal value is 0.495 standard deviation below average. The middle of n is equals to 5 where standard normal value is at the average, 0 standard deviation from the average. So in that case हमारे पास मल्टीपल वैल्यूज जो है वो शो हो रही है मीन की, जहाँ से हमने स्टैंडर्ड डेविएशन एक्वायर की है और स्टैंडर्ड नॉर्मल फंक्शन ऑन एन एवरेज कैलकुलेट किया है। Now here this table of rankings from the statistics and biology table gives these expected values. For larger n, space is saved by just giving the positive values. जब हम positive values की बात करते हैं तो वहाँ पर n is larger, but we are saving the space in the curve. And the negative values are mirror image of the positive values since the standard normal distribution is symmetric about its mean of 0. इसलिए क्योंकि जब हम standard normal distribution की बात करते हैं, standard normal curve की बात करते हैं, so this just shows a mirror value of positive values. अगर इसका mean सेंटर में एग्जिस्ट करता है और हमने ये भी कहा है कि दिस इज एसिमेट्रिक, तो एसिमेट्रिक का मतलब ये है कि पूरा का पूरा सिमेट्रिकल कर्व है। जिस तरह की अपीयरेंस राइट हैंड साइड के ऊपर है बिल्कुल वैसी ही अपीयरेंस लेफ्ट हैंड साइड के ऊपर भी होगी कर्व की। तो इसका मतलब ये है कि द नेगेटिव वैल्यूज आर द मिरर रिफ्लेक्शन ऑफ द पॉजिटिव वैल्यूज। तो बिकॉज द कर्व इज सिमेट्रिकल एंड इट इज एसेंट्रिक टू 0, तो इसका मतलब ये है कि जो राइट हैंड साइड की वैल्यूज हैं बिल्कुल वैसी ही अपीयरेंस लेफ्ट हैंड साइड के ऊपर वैल्यूज की भी होगी जो कि मिरर रिप्रेजेंटेशन शो कर रही हैं नॉर्मल कर्व की। Now here we can check for normality. that if x is a normal curve, x is a normal random variable, how do ordered values of x and x iota relate to the expected order z values of expected value of zi? So here z is equals to x minus mu over sigma, where x is equivalent to mu plus sigma z. For normal case with mean mu and standard deviation sigma, the expected values of the data xi will be a linear rescaling of standard normal expected values. जब हम expected values की बात करते हैं in case of normal random variable, जिसमें हमने anticipate किया है कि mu is equals to 0 and sigma where standard mean is equivalent, where normal mean is equals to mu and standard deviation is equals to sigma, तो यहाँ पर हमारे पास जो expected value है x iota की वो linear rescaling की form में show होगी, where e of x is approximately equivalent to mu plus sigma expected value of z iota. तो यहाँ पर जो observed data है xi का will be approximately linearly related to expected z iota, where x iota is approximately equivalent to mu plus sigma e of zi. So that is something which is a true representation of check for normality. If we plot the ordered x values versus expected zi, we should see roughly a straight line with intercept mu and slope sigma. तो यहाँ पर जो intercept है हमारे पास वो show करता है mu को, और जो slope है वो determine करता है sigma. जो भी उसकी erection है या जो भी उसकी peakedness है वो determine करेगी standard deviation, और जो उसकी presence है from the x-axis that will be determined through the mu, which is mean. The normal plot, in order to plot the data and check for normality, we compare our observed data to what we expect from the sample of normal data. Now here let us consider another example of lifetimes of springs under 900 nmm square stress. अब यहाँ पर हमारे पास जो values हैं वो दो columns की form में exist कर रही हैं, where I is the number of observations, x is the original number of is the original outcome, and expected zi is the expected value which we have taken from the level of stress. कि जब हम stress apply करते हैं first observation के ऊपर, which is showing 153 nmms, तो nmm square, तो वहाँ पर हमारे पास जो expected z value appear हो रही है वो -1.539 है. When we have applied the test on the second observation with 162 x value, we have come up with -1.001 expected zi and so on. So in that case, जब हमने इसकी plotting की है 900 stress के ऊपर of springs की, तो lifetime of springs at stress level is shown in the given table. Exactly हमारे पास जो values appear हो रही थी वो -2 से +2 के फॉर्म में appear हो रही थी. -2 से +2 तक का की जो रेंज में हमारे पास values हैं वो appear हो रही थी, और उनकी plotting हमने identify की है with the given plotting of lifetime, which is presented to us in the form of x. इस फॉर्म में जब हमारे पास expected value of z हमने plot किया है, तो यहाँ पर हमारे पास एक fairly linear plot indicate हुआ है, जिसमें जो data है this is pretty similar to what we expect from the normal data. Remember, हम यहाँ पर normality check को identify कर रहे हैं कि how to check for the normality in terms of identifying the level of stress over the expected z value. तो यहाँ पर जो plotting originally हमें show हो रही है वो एक linear tendency को show कर रही है, which is showing an increasing trend. कि जब हमारे पास -0.2 से values increase होना शुरू हुई हैं towards 0.2, this is showing an increasing trend which is linear in consideration. जब हम इसको मैच करते हैं फ्रॉम दी नॉर्मल प्लॉट, तो हमारे पास जो नॉर्मल प्लॉट है वो इंडिकेट हो रहा है एट द लेवल ऑफ 950 स्ट्रेस लेवल के ऊपर, और ये एक और ग्रुप है जो कि हमने इससे पहले मॉनिटर किया था, which is also showing a linear tendency. To compare results from different treatments, we can put more than one normal plot on the similar graph in order to check for normality and for the comparisons. The intercept for the 900 stress level is above the intercept for the 950 stress. कि जब हमने इसको नॉर्मल केस के साथ प्लॉट किया है तो हमें ये पता लगा है कि जो 900 स्ट्रेस लेवल का जो प्लॉट है वो 950 स्ट्रेस लेवल के प्लॉट से हायर लाई कर रहा है, विच इज़ अ वेरी इंपॉर्टेंट एरिया टू बी नोटेड हेयर। कि यहाँ पर जो हमने प्लॉटिंग की थी 900 की, वो पिंक स्क्वायर्स के साथ शो हो रही है, और जो 950 स्ट्रेस लेवल है वो ब्लू डायमंड से शो हो रहा है या ब्लैक डायमंड से शो हो रहा है, व्हाटएवर। सो दैट इज आल्सो शोइंग अ लीनियर टेंडेंसी विच इज इंक्रीजिंग, but this linear tendency or increasing with higher level of stress is locating at the lower curve, whereas the higher lower curve, lower stress is presented with higher curve. अब कर्व हायर और लोअर कब होता है? हमने अभी थोड़ी सी देर पहले डिटरमिन किया था कि जब भी हमारे पास वेरिएंस के अंदर या स्टैंडर्ड डेविएशन के अंदर चेंज आता है तो कर्व की पोजीशन चेंज होती है। तो यहाँ पर हमारे पास दो डिफरेंट ऑब्जर्वेशन, दो डिफरेंट स्ट्रेस लेवल्स जो है वो अप्लाई हुए हैं, मीनिंग दो डिफरेंट ट्रीटमेंट्स जो है वो अप्लाई हुई हैं, और यहाँ से हम रिजल्ट्स को एनालाइज करना चाह रहे हैं। तो वो केस जिसके अंदर हमारे पास ज़्यादा स्ट्रेस था, मीनिंग 950 स्ट्रेस था, वो कर्व बिलो शो हो रहा है एज कम्पेयर टू द वन विच इज होल्डिंग लेस स्ट्रेस. So in that case we can easily identify that there must be change in variation जो कि between those curves exist करता है, लेकिन within the curve is the similar one. So the intercept for 900 stress is above the intercept for 950 stress, indicating the mean lifetime of 900 stress group is greater than the mean of 950 stress group. इसका मतलब ये है कि अगर ये दो different curves हैं और इन दोनों के curves की position parallel है, तो इस केस में हमारे पास जो लाइफ टाइम है 900 स्ट्रेस ग्रुप का और जो लाइफ टाइम है 950 स्ट्रेस ग्रुप का, वो डिफरेंट है, and that is why their y intercept is different, whereas the slopes are similar, indicating that the variance or standard deviation is similar in between. So these plots are done in Excel. In Excel you can either enter values from table or generate approximations to these table values. One way to generate approximation to expected Z values is to generate evenly spaced percentiles of a standard normal Z distribution. अगर हम percentiles के ऊपर debate करें या percentiles की basis के ऊपर हम data को identify करें, तो उसमें हम अपनी हर observation को 100 से multiply कर देंगे. Meaning if I is the observation, so I minus 0.5 over n को हम 100 से multiply कर देंगे. तो usually हमारे पास ये एक common percentile conversion का method है. So that is one way to generate approximation of expected Z values in order to generate evenly spaced percentiles of a standard normal Z distribution. The ordered X values corresponds roughly to particular percentiles of a normal distribution. For example, if we had n is equals to 5 values, the third observed ordered values would be roughly the median or 50th percentile. A common method is to use percentiles or corresponding to 100 into I minus 0.5 over n values. Now here we are identifying an application of normal distribution in which in 1960 to 62 there is a public health service health examination survey in which 6,672 Americans were studied, and they were identified in the age of 18 to 79 years. The women's height were determined actually in the test and in the analysis, and the women's height were approximately normal with 63 inches and standard deviation of 2.5 inches. What percentage of women were over 68 inches tall? यहाँ पर हमने एक नॉर्मल कर्व को आइडेंटिफाई करना है जिसमें हमारे पास जो मीन हाइट्स हैं वो अपेयर हो रही हैं 63, मीनिंग कि जितनी भी हमारे पास वुमेन थी इन द बिटवीन द एज ऑफ 18 to 79 अकॉर्डिंग टू द गिवन सर्वे ऑफ अमेरिका, यहाँ पर हमारे पास इन दिस रेंज जो हमारे पास मीन हाइट डिटरमिन हो रही है वो है 63 इंचेस, और जो उनके अंदर वेरिएशन है स्टैंडर्ड डेविएशन है दैट इज 2.5 इंचेस. तो वी नीड टू आइडेंटिफाई दैट व्हाट इज द probability that x is greater than or equivalent to 68. So that is something which we are about to study. So in this case, x is determining the height of the woman, where probability of x is greater than 68, and probability of z, which is greater than 68 minus 63. Z is the standard normal function divided by 2.5, which is the standard deviation, where p of z is greater than or equivalent to 2. 68 minus 63 is equivalent to 5 divided by 2.5. 5 divided by 2.5 is equivalent to 2. So we are checking 2.0 in the normal curve, in the normal graph. जो हमारा जो टेबल था उसके अंदर हम 2.0 को प्लॉट करेंगे और 2.0 को देखेंगे कि उसके अगेंस्ट क्या वैल्यू शो हो रही है, which is 0.4772. We will deduct 0.5. We will deduct 0.4772 from 0.5. Now why we had made the deduction? Because we want to know that what is the probability, what is the percentage of people who are above 68. तो हम यहाँ पर एनालाइज करना चाह रहे हैं बिटवीन का केस नहीं बल्कि अबव का केस. तो यहाँ पर अगर हमारे पास ये एक नॉर्मल डिस्ट्रीब्यूशन का कर्व है और हमें ये पता है कि मीन हमारे पास 63 है और वी वांट टू नो कि कितनी women हैं जिनकी हाइट 68 इंचेस से ज़्यादा है. सो वी वांट टू नो दिस एरिया, जो कि मैंने आपको थोड़ा सा शेड करके दिखाने की कोशिश की है कि वी आर इंटरेस्टेड इन नोइंग दैट एरिया विच इज़ अबव 68 and we are assuming that the probability of x is that portion which is not between mean, not between the given value, but is higher than the given value. So if the given value is showing us the normal curve that x minus mu over sigma के reference से हमारे पास जो value आई that is 63 minus 62 over 2.5 which is 2. हमने 2 को 2.0 के against table में लोकेट किया है और टेबल के अंदर जो लोकेशन पे हमें जो वैल्यू मिली है दैट इज एक्चुअली द एस्टिमेट, दैट इज एक्चुअली द z वैल्यू इन नॉर्मल टैबुलेशन जो ऑलरेडी टेबल के अंदर मेंशन है. दिस होल्ड्स द रिजल्ट ऑफ 0.4772. अब यहाँ पर 0.4772 का रिजल्ट एग्जिस्ट करता है. दिस शोज 0.5. वी आर नॉट interested in knowing any value between 0.5 to 0.477, but we want to know value which is greater than 0.477. So for this we have deducted 0.4772 from 5 to know that what is the remaining area. So the remaining area is 0.0228, which shows that just 2% of the population, women population, is holding height which is greater than 68 inches. So that is something which shows, which is actually determined from this sign. क्या ये वाली साइन हम उस वक्त तक उसको राइटली एनालाइज नहीं कर सकते जब तक हम इसको प्रॉपरली अपने प्लॉट के ऊपर, अपने ग्राफ के ऊपर प्लेस ना करें कि हम एक्चुअली किस चीज़ का एरिया आइडेंटिफाई करने में इंटरेस्टेड है. हम एक्स का एरिया अबव द गिवन लाइन आइडेंटिफाई करने में इंटरेस्टेड है, बिलो द गिवन लाइन आइडेंटिफाई करने में इंटरेस्टेड है, या हम इन बिटवीन एरिया को डिस्कस करें. सो इन दैट केस we can easily identify with the plotting that what is the actual presentation of the values in the given graph sheet. So now let us discuss that how we can approximate normal distribution to binomial. A binomial distribution is represented through mean NP and standard deviation NPQ. So in that case, of a binomial distribution of n equivalent to 10 values and p is holding 0.5 value, तो definitely q की value भी हमारे पास 0.5 ही होगी क्योंकि q is equivalent to 1 minus p. P is the probability of success and q is the probability of failure, where probability of failure can be calculated by 1 minus probability of success, which is 1 minus p. So if we are given with the p is equivalent to 0.5, then q is definitely equivalent to 0.5 again. So mu is equivalent to np, which is 10 into 0.5, which is 5, and sigma square is npq, which is 10 into 1. So that is 2.5. 10 into 0.5 into 0.5, this is 2.5, which is 1.58. So here, if you are interested in knowing that probability of x is greater than or equivalent to 7 from the binomial, it shows that 0.172 is the value. Probability of x is greater than or equivalent to 7 through normal distribution will be stated as probability of z is greater than 6.5 minus 5 over 1.58, where 6.5 is the mean and is the given value, and 5 is the mean, 1.58 is the standard deviation. From here we have taken 1.5 over 1.5, that is approximately equivalent to 1 or 0.95. 0.95 को जब हमने locate किया है अपने normal distribution के table के अंदर, so we have received a value of 0.3289. When we have deducted from 0.5, we have received 0.1711, which is almost equivalent to binomial. So we can say that normal distribution को अगर हम approximate करना चाहें binomial के ऊपर, या हम binomial को approximate करना चाहें normal के ऊपर, तो वो हमें equivalent results show करते हैं. So this is a line which is also a very smooth curvy line which is determining the relationship of mean and variances with the normal plots of binomial curve. The normal approximation is good if the normal curve has the same mean and standard deviation as binomial, which is usually an assumption. But if अगर हम approximation की बात करते हैं normal to binomial में, तो हमारे पास ये दो conditions meet होनी चाहिए कि the normal curve has by all means the similar mean as of binomial one and the similar standard deviation. Therefore NP is greater than 5 and NPQ is also greater than 5. Secondly, the continuity correction is made, meaning whenever we are running with the normal approximation to binomial, it will be good if a continuous correction is made. So in this session, we have identified that what is actually a normal distribution. We have analyzed that normal distribution is a continuous distribution in which we are taking one single point in consideration and identifying that the area under this curve is equivalent to 0. With the combination of multiple points, with each having area under the curve equivalent to 0, we get a symmetric normal distribution curve with mean, mu and standard deviation sigma, where mean determines the location of the curve on the normal plot, and standard deviation identifies the peakedness and the density of the function. We have also analyzed that how can we check normality, how can we check for normality. We can plot two different curves, one is the standard curve and the other one is the plot according to the given values, and if the mean of the curve is similar, then it will be showing through the straight line. And if the standard deviations are similar, it will be having a parallel combination of the curves. Then we have analyzed the normal distribution towards the binomial distribution or normal approximation to binomial, and we have seen that if the mean and standard deviation of normal distribution are equivalent to the mean and standard deviation of the binomial, then we can have the right approximation of normal to binomial. So these are few areas which we have taken into consideration in this session. In our future lectures, we will be disclosing multiple more relationships with the normal distribution. Thank you so much for this time, and thank you so much for your patience of listening. Allah Hafiz.